Hello and welcome back for another VMK in the C++ series. In this VMK, I'll be talking about unique pointers, what they are and how we can use them. I'm going to start off with a new project and I'll call it unique pointers. It's just going to be a Win32 console application and the application settings are going to be console application. I'm going to use precompiled headers and everything else is as shown here. Okay, so I have my standard project. If I just run it right now, we should get it to display hello onto the screen because I'm using printf here to display a message to the screen. So, unique pointers, what are they for? Well, they're very handy when it comes to working with dynamic memory. When you're writing a program that uses either the new operator or the memory allocators from C, then you need to be very careful to make sure that you delete that memory, because if you don't, you're going to have a memory leak. So let me show you a chunk of code here. Let's say that at the top here, I'm going to have two different kinds of error conditions, error 1 and error 2. Error 1 I'm going to set to false, and error 2 I'm going to set to true. In a second, we'll be creating this class called myClass, and it's going to be a dynamic chunk of memory that we're going to be allocating here using the new operator. Then we have some logic. If this error is true, then we're going to go into this if statement and we're going to print off a message saying error 1 has occurred. Then we're going to delete this dynamic memory and then we're going to return 1. Down below here, we're going to have another if statement that checks for error state number 2. If it's equal to true, then we're going to print off error 1 is okay, error 2 is bad, and we're going to return 2 as opposed to return 1. Finally, if we don't have any errors, then we're going to go in here and inside of our class we're going to have a print statement that will just print something to the screen. And then finally, we want to deallocate the memory that we allocated up here, so we're going to call delete and we're going to return 0. So if you take a look at this code and you're paying attention, you'll notice that there is actually a memory leak in this chunk of code. And it's basically only going to happen if you go inside of this if statement, which is how it is currently set up. So if we have this set to true, we have no memory leak. If we have this set to false, or we have this set to false, then we also don't have a memory leak. The only conditions that we have a memory leak is when we have this set to true, because we'll go into this if statement, we're going to print these messages and we're going to return. But notice I specifically did not add this delete operation here before the return statement. This is very easy to make. Now imagine that we had a lot of code here where we had a lot of different branches, a lot of different logic, maybe this goes off to a separate function, things like that. You need to be able to keep track of where you've allocated your memory and where you delete it so that when you do lose scope of it, you need to call the delete operator to deallocate the memory. Now I'm going to create this class right up above so we can run this code. Okay, so here's my declaration for my class. So my class has a static integer here called counter, and it has a ID value which is also an integer. Inside of the constructor, anytime we allocate new memory for one of these class objects, we're going to increment the current counter and save that inside of our member variable. And then we'll display it onto the screen we've constructed and the actual number for the class object that we're constructing. In the destructor, we're going to show destroy and the ID so we can keep track of which one of our class objects we're creating and destroying. The print statement is just going to print the message print and then the actual ID value that we're storing here inside of our member variable. Because counter is a static integer, we need to declare some memory for it, so we do that outside of the class, and I'm just initializing it to 0. Here this should be a capital letter M for our class definition. Let's run through this and make sure that everything's working fine. I'm going to first change both of these to false, and if I press Control F5 on the keyboard, we'll build and run it, and we can see that we construct one, we print one, and then we destroy one. So this guy basically got created here. We printed constructed one, then we went down past these two error conditions, and we called the print statement, so we had print one, and then when we called delete, we showed the destroy one on the screen. So now if we have error state 1 as true and rerun this, we notice we still construct one, we have error one, and we destroy one. So that's exactly what we were expecting. And if we have true for the second error and false for the first error, this is where we have our memory leak. So we run our code and we can see we have construct 1, error 1 is okay, error 2 is bad, and then we return. Notice that there is no destruct 1. So I basically leaked some memory because I allocated some using the new operator, but I never deallocated it before I exit out of my program. This is where unique pointers come in very handy, because the way that unique pointers work is you put in a pointer to some memory into the unique pointer, and the unique pointer from then on keeps track of that memory. As soon as the unique pointer goes out of scope, it will automatically call the delete operator, as here, so that your memory gets deallocated. Now what do I mean by scope? Well, inside of this function here, we are inside of a functional scope. Inside of this if statement, we're inside of this scope. So anytime you have braces like these, you're going into a different scope. So if we declare our memory outside here, then it's completely valid anywhere until we exit out of the current scope, which is outside of these brackets. If I were to declare it inside of here, for instance, then as soon as we exit out of this if statement, if we're to fall out of the if statement down below, or if we return out like this, then we lose scope from these brackets and then our memory would get deallocated automatically. So to demonstrate this, what I'm going to do is I'm going to take all of this code and wrap it up inside of a function so that we can have an easier understanding of what's going on here. So just going to take all of this, put it inside of the foo statement. So now everything is inside of the foo function, so therefore I'm inside of the foo function scope. If I rerun this exactly the same as we did before, oh, I forgot to return a value here. I'm returning a void, so I don't actually need to return a value. Let's give this a try. Okay, so we see here we construct one, we have error, error 1 is okay, error 2 is bad, and then we return. So we still have our memory leak because we are not using a unique pointer. So let's introduce a unique pointer here to see how this differs. Well, firstly, before we use a unique pointer, we need to include some files inside of our stdafx.h, and unique pointer is defined inside of memory. I know that because if we were to open up MSDN and look up the unique pointer class, we can see that down here it says the requirement header is memory. So that's what we need to make sure we include. So once we do that, we need to go into stdafx.cpp, compile that so that it is included inside of our precompiled headers, and then inside of our code we'll be able to use our unique pointer. So inside of our foo function, right here, instead of declaring our dynamic memory this way and saving it inside of this variable here, we're going to use our unique pointer instead like this. So we declare an std unique pointer. We need to pass in what kind of data type we're going to be having a pointer to, and that's going to be a my class because that's what we're using up above. And we need to give our unique pointer a name. So I'm going to be calling it up for unique pointer and class. And then finally, we need to pass into the constructor here our pointer to that new memory. So we allocate new memory the exact same way that we did before by using the new operator. And what we want, new, well, we want a new myClass object. So now our unique pointer has memory stored inside of it. To use our unique pointer, we use it exactly the same way that we did before. So for instance, if I wanted to call a print function here, we just use the unique pointer and call print. We no longer need to call delete because our unique pointer will take care of that for us. So we can delete the delete statements and give this a try to see what it looks like. So I'm going to save this, build it, and let's see here. I'm going to have no error, so I'm going to have false and false. Notice we have no delete operator. Let's take a look at what happens now on the screen when we run this code. Notice we construct one, we print one, and we destroy one. So our unique pointer was able to delete our memory even though there were no delete operations, because our unique pointer is smart enough to delete everything that it's containing inside of it as soon as it loses scope. So now if we were to set this back up to true, this is where we had the memory leak before. We rerun it and notice we have construct 1, error 1 is okay, error 2 is bad, and now we still do destroy 1 even though there is no explicit delete operation. So our unique pointer is doing all the work for us, which is great. Now you may be wondering, well, how is it that you use unique pointers if you have an array? You may be familiar with using the delete operator on arrays. Let me comment this out. So let me add in some code here to allocate an array of dynamic memory. So if we have an array of dynamic memory, we would want to have some sort of size defined. So I'm going to define it as having 7 items. And here we're going to call the new operator for our myClass object. So we're going to get returned to us a pointer to a myClass object, and this time it's going to be an array. And immediately I'm just going to delete everything out and then return 0. So if I run this through and take a look, we see we call construct 7 times and we call destroy 7 times. So we allocate 7 myClass objects and then we immediately destroy 7 of them. Notice that we do need to have this square bracket operator here. As soon as we delete that, we will run into problems because C++ has this mapping that if we use new with an array, you need to have the brackets after the delete operator. If you do not, then you're going to have a memory leak, and I can demonstrate that as well. So notice here I'm calling construct 7 times, but I can only destroy the first one before I get an assertion failure because I am calling the wrong delete operator. Same thing is true for the regular case. If I were to quickly rewrite this code back to how it was before, if we're to have just p class, call new on that guy, and then like this, p class. So this code here is fine. It constructs 1 and it destroys 1. But if I were to do delete with square brackets, notice that here I am not allocating memory for an array. I'm just allocating one object. So if I try to run this, I also get an assertion failure on the delete call. So you do need to have the mapping correctly between the square brackets on the new operator and the square brackets on the delete operator. If you don't have that mapping correctly, you will get a problem. Okay, so going back now to using unique pointers. Well, we saw how to use a unique pointer for a regular one object. To use a unique pointer for an array of objects, it's basically exactly the same, but you do need to have those square brackets in play. So I'm going to uncomment this code, and here I'm going to be allocating an array of myClass objects. And how many of them do I want? Well, let's do 7 again. Finally, down below here, we now need to say, well, which one of these do we want to print? Well, I got to change the notation here from the arrow to the dot. And now let's build this and give it a try. So notice here we construct 1, 2, 3, 4, 5, 6, 7. Then we had error 2, so we destroy 1, 2, 3, 4, 5, 6, 7 all in the reverse order. And if we do not have any errors, then we should see we print 4, which is this one here because we're starting at 0 index. So 0 would print 1, 1 would print 2, 2 would print 3, 3 would print 4, which is what we saw on the screen. So once again, if you are using an array of pointers, then you need to have the square bracket in here. If you don't have the square bracket in there and you attempt to do this, then you will have that same assertion error that we saw before. So one thing just to be aware of when using unique pointers with arrays. Okay, what other things can you do with unique pointers? Well, let's go back into this example here. We created a unique pointer, and I'm just going to create one myClass object. And down here, I showed you how to call the print function using the unique pointer. Well, you don't need to use the unique pointer directly to call your class's functions. Instead, what you can do is return the pointer from your unique pointer and use it directly. So for instance, if I wanted to get my myClass pointer, I'm just going to call it pClass. what we can do is call upClass.get. What this will do is it'll return to us the actual pointer that is stored inside of our unique pointer. So that is now referenced here inside of this variable here. So I can use this variable pClass to call the print operator as I would normally do. Now the interesting thing here though is the unique pointer still has possession of our memory. So even though I have a pointer outside here to that memory, the unique pointer is still responsible for it. So even though I returned the pointer value, I didn't actually delete the unique pointer reference to that memory. I still have that memory. So this is going to work fine and we will not have any memory leaks. So let's run this to take a look. Notice that I'm constructing one, I'm printing one, and I'm still destroying one. So even though you're calling get to get the pointer out of our unique pointer, we are still possessing the memory that the unique pointer is containing. Now this is very helpful when you're trying to write code that's compatible with other libraries or functions that require direct pointers to objects. So you can still use unique pointers in this sense. You just call the get operator on the unique pointer class to get the actual pointer that is being stored in there. So notice the difference here. If I use unique pointer class with the dot operator, I have some extra functionality here that is not belonging to the my class at all. If I want the functionality that belongs to my class, then you would have to use the arrow operator, and then you see here are all the operations that I can work on for the my class. So there is a distinction here between the dot and the arrow. Okay, so that's one of the things you can do is you can get the pointer. If you actually wanted to replace the pointer that the unique class is storing, you would call reset. So let's give that a try. So I'd call upClass.reset, and here it's expecting us to pass in a pointer of the same type that we defined up above, so it still has to be of a type myClass, and you can define it however you want. So let's say I wanted to allocate some new memory for another myClass object. I would do it this way. So now, what do you expect to happen? It previously had this first set of memory inside of the unique pointer, but I'm now resetting it to some new dynamic memory. So let's run this through and take a look at the output. Notice that we constructed one, we printed one because we had the print statement here, and then we construct number 2, we destroy number 1, and then we destroy number 2. So what's happening here is as soon as we call the reset operator, we are basically going to deallocate what was previously stored inside of the unique pointer, and then we allocate memory here for this new guy. Once we lose scope, we deallocate memory for that second new guy, so we basically are ensuring we don't have any memory leaks. Again, this is very handy to be able to manipulate your memory dynamically without having to worry about memory leaks. The other thing you can do with the unique pointer is, for instance, you can call unique pointer class.release. What release will do is it actually releases possession of your pointer, but it does not destroy it. So let's take a look at this. If I were just to call unique pointer release as this and give this a run, notice what we do here. We construct 1, we print 1, we construct 2, we destroy 1, but we never destroyed number 2. So to simplify this a little, let's delete all of this stuff and rerun this. So notice we construct 1, but we never actually deleted 1 because we released possession of our memory here, but we never actually called delete. Releasing basically means the unique pointer gives you the pointer to the memory and says that the unique pointer will no longer manage that memory that that pointer belongs to. So you need to make sure that if you use the release operator for the unique pointer, that you will call the delete operator yourself. So here we would have to do something like this. So release will actually return to us a pointer to our object that we're storing in here, and then we would have to call delete on pClass to be able to deallocate that memory. So now you can see we constructed one and now we're destroying it properly, so we do not have a memory leak. So those are the three most important functions that belong to a unique pointer. Get, to get a pointer, but the unique pointer still has possession of it. Release will return the pointer, but it does no longer have possession of it. And reset, which means give me a new set of memory that I want to keep track of, and the old one I will automatically release for you. Okay, well let's move on to something a little bit different. We've been looking at pointers to memory that we allocate using a new operator, but let's take a look at memory that we allocate without using the new operator. Instead, we use a function that will allocate some memory for us or some other means. A good example of that would be the file operations. So here, what I'm doing is I'm creating a pointer to a file. I'm going to be calling the fopen function, and this guy will be looking for a file called testfile.txt. It's going to read it as a text file, and if it can find it, it's going to go down below. If it can't find it, then I'll just print to the screen, cannot open the file. If we go down here, then we have some memory allocated with our file pointer. So from then on, we need to, operate on that file however we want. What I'm doing here is I'm allocating some memory, resetting it all to 0, and then I'm going to use the read operation to read the data that's stored inside of that file. Print the data to the screen, and finally to deallocate the memory that was allocated by the fopen operation, we need to call fclose. So this here is the equivalent of calling new. This here is the equivalent of calling delete. So for this to actually work, we need to have a test file. If I were just to run it right now, we'll see a message to the screen saying cannot open the file because the file doesn't exist. So let's create this testfile.txt. You'll want to create just a standard testfile.txt here inside of the root of your project. And inside it, I've just put some text data stored inside of this test file used to demo the unique pointer class. So now that we have that in play, we can go run our code and we can see the file is open, and here's the text that was stored inside of that file displayed to the screen. So how would we use the unique pointer in this case? We've seen already that to use the unique pointer, you would want to do something like this, where here you need to specify the type. Well, the type is a file, so we type file in here. Inside of the constructor, how is it that we can call new? Because new, we don't have a new operator. Instead, we have a function that operates on that. So we can't do that directly. To get around that, we write the code this way. I'm going to take this and put it right below our if statement. And after here, we know that the file pointer is already allocated with some memory. So here we can just replace this with file pointer. Now that would almost work. However, we still have a problem. The unique pointer is going to try to deallocate the memory for us by calling delete. So that's not what we want because we want to call fclose. So let me take this out and run it through and take a look at what happens. We get an assertion failure whenever we're exiting the scope of our function. So that's no good. The way we can override the default delete operation so that it doesn't try to call delete on our file pointer, since that's not the way you deallocate a file pointer memory, is we need to specify our own deleter. Now if we take a look at the MSDN file, you'll see that by default here, you can actually see it in the tooltip, the first parameter is a file, and the second parameter right now is a standard delete operator for a file, but that's not what we want. So in here we can see the second parameter will be a default delete operator, but we need to specify our own deleter for our file handler. To do that, you'd basically say comma, and I don't want to use the default deleter, I want to use a file deleter. So what is a file deleter? Well, we need to define this. So right up above here, we can declare a file deleter as following. A file deleter will have a overloaded operator where we pass in a file pointer. And what do we need to do? Well, to deallocate the memory, we call fclose on the file pointer, and I'm just going to stick in this print statement to show that we are actually calling this code. So now, when we go and run this, we can see that the file was opened, we displayed the text to the screen, and the file was closed because our unique pointer was calling the file deleter when we left scope from this main function call. So that's basically it for the unique pointer. You should understand how to use the get, how to use the release, how to use the reset functions within the unique pointer, and you should understand how it is that you can create your own deleters if it isn't the default ones that you want to use. The default ones for delete and delete with the square brackets are provided for you, but if you have any other data types that have special kinds of code needed to delete your memory, then you do need to make your own custom deleter using this structure here, where you just overload the operator and pass in whatever it is that you want to delete in here. The parameter that gets passed into this overloaded operator has to be a pointer to whatever you passed into here, so that the unique pointer understands how to convert everything over for you. Okay, so I hope this was helpful. If you have any questions about unique pointers, feel free to head on down to the forums and click on the thread link for this VMK and post your questions there.